Welcome back to the final built-in function video. It's been a bit of a marathon, but hopefully somewhat interesting because they're kind of all over the place. They do very different things. And the last one is called zip, and it might be the weirdest one of all of them. If I read the explanation, it's not going to make a lot of sense. It makes an iterator that aggregates elements from each of the provided iterables, returns an iterator of tuples where the ith tuple contains the ith element from each of the argument sequences or iterables. The iterator stops when the shortest input. Okay, that's enough. What it does really is imagine that we have two lists of numbers and they're the exact same length. It's going to make a new list where it pairs up the first two numbers from the list and then the second two numbers and the third two, it zips them together. Imagine, a list on the left and a list on the right. Take the first one from each, put them together. And then you move down and you take the second one from each and put them together. So here's an example. If we zip 1, 2, 3 the list and 4, 5, 6 the list, we end up with a list of tuples like this, 1, 4, 2, 5, 3, 6. And that's if we convert it to a list. By default, it returns an iterator of tuples, and we have to convert it to a dictionary if we want a dictionary or a list if we want a list. So let me show an example. I'll do nums1, and we can go with 1, 2, 3, 4, 5. Nums2 equals 6, 7, 8, 9, 10, like this, if I can spell. And now if we zip them together, like this, we get this iterator of tuples. And what we actually need to do is we can turn it into a list. So I'm going to save this to a variable, and I'll just call it z. And if we do list of z, you can see it's a list of tuples, 1 and 6, 2 and 7. I could also do a dict of the same thing, and we get 1 is the key and 6 is the value. So what it's doing, hopefully you can see where the name zip comes from. It's pairing up this and this, this and this, this and this. If we have uneven lengths, well, actually, even before that, let me just show, it does go from left to right. So if we switch the order, and we do nums2, nums1, and now if we do list of z, we get 6, then 1, rather than 1, then 6. So the order matters. And the items don't have to be exactly the same length, although I'll show you what happens. Let's redefine nums2 and have it go to 11 and then 12. And now if I re-zip them, I'll go nums2 first. And if I print it, you'll see it stops as soon as the shortest iterable is exhausted, as soon as we reach the end of whatever the shortest thing is. So we don't see 11 and 12 anywhere because we were limited by nums1. Another thing to mention, we're not limited to, 2 items at once. I could also have something called words, and I'll just put in hi and LOL. I guess that's not really a word. Haha, and how about smiley emoji? So we have 4 of them. Now, if I do list of zip, and let's start with words, and then nums1, and then nums2. What do we get? We get a list of tuples, each containing 3 elements now. And also, remember, this is the shortest one, so it limits how far the others go. We stop when we hit the end of words. So I have a more complex example of when we would use this, but I want to start by just showing you one more thing, which is that we can also use the star operator to unpack a list in this example. And what will happen, here's a list of tuples, 0, 1, 1, 2, 2, 3, and so on. If we pass in star 5 by 2, which is the name of the list, it's going to take all these tuples out of the list and pass them in individually. So it would be the same thing as running zip with this element, this tuple, comma, this tuple, comma, this tuple. And what it will do is then go through and pair up all these things here. Pairs is the wrong term, actually. It's going to take the first item from all 5 and put them in one tuple, and then take the second item from all 5 and put them in another tuple. So we can use that star to unpack things. And it's pretty common when we work with more complex data structures.